Good afternoon. Good afternoon. Assalamualaikum everyone. Okay, before I start, I would like to discuss on your midterm date. Midterm, can we do on the same Thursday during class hour on 16 February? Is it okay? You want it to be earlier? Okay, any clashing? Any back to back? How difficult? It's based on the CO. Okay, wait, confirm 16 class hour 2 to 3:30 p.m. Yes, you have clashes, Lona? Why? What's the problem? May I know what's the problem? Petrochem. After this class. 16. Okay, anyone else Petrochem? Same day, 16. How many of you? A lot. Or you want to do it on Friday? Friday morning. During our class, Friday morning. Okay. 17. Okay, so midterm will be on 17, 9:30 to 11. Venue would be that sub. Okay, agree, huh? Anyway, the chapters based on the CO course outline, midterm will cover CLO2 and CLO3, where CLO2 is this one, construct a chemical process flow diagram using hierarchy of process design. Wait, sorry. Give me a minute. Okay, CLO2, which is chapter 2, the hierarchy of design. And CLO3, which is today's topic, separation train. Okay, for multi-component mixtures using heuristic of sequencing. Okay, so chapter 3, we will start on CLO3. Before, I think chapter 3, we will have a few sessions. Today, I will just intro you what is, how to do the separation, how to do the sequencing, okay, and what are the separation units involved. So next class, enough time. Tomorrow, we will do a few exercises. Okay, if we manage to finish the theory part today. Okay, so for your midterm, I will see until which part that we manage to cover in chapter 3. Okay. For chapter 3, I would suggest you to, for further understanding, I would suggest you to read the textbook. Okay, there are a few more examples in the textbook. The one in the slide is I extracted only a few of the examples. It will be for the midterm around 2 to 3 questions and 15%. This week is week 5, is it? Week 5. So basically next week I will finish I think I will finish chapter 3 by next week. So week 7, Dr. Ng will take over the class. Okay. Okay, let's start on chapter 3. In what subject that you have learned about distillation? Separation of mass transfer. Okay, so you already have the basic knowledge on the relative volatility. Forgot already. So that is not new term, you already know, right? How the relative volatility affecting the separation process. The higher the relative volatility amount, the easier the separation process, right? Huh? No. Different thing. We'll go through again this bit. Okay, so we are done for first part. Today we will focus on the detailed process synthesis, which is on the sequencing process. Here it is fall under part 2, the separation train synthesis. In previous chapter, we had gone through the heuristic on the chemical distribution, the input, the output. Okay, so now we will focus only on the separations. Okay, almost all chemicals require separation. The purpose is to purify the feed. Purify the feed, whether it is a reactor or any required unit of. If the feed need to be purified, then it's always to use the separation system. Okay, and to recover the unreacted species for recycle to reactor, and to separate and purify. Separate and purify the products from a reactor. Usually it will involve before reactor and after reactor. Okay, so this is your reactor system. So for the feed to enter the reactor system, a certain feed you cannot simply pass the feed without any treatment. Okay, certain process you will need to do the pre-treatment before the reaction. So for the feed separation system over here, example here, the raw feed, fresh feeds, you will need to prepare. So you will need to separate the inert or any poisons, inert or any impurities over here. Okay, this example it mentioned catalyst poisons. Okay, and then once you purify the feed, this mixer is required once you have the recycle system. If you have the recycle stream, then you need the mixer. If not, the fresh treated feed can directly enter the reactor. Okay, so the reactor where the reaction occur. Effluent of reactor might consist of mixtures of products. Okay, so these mixtures of product, perhaps mixtures of phases, you will need to separate them. You need to purify them. Okay, so in order to obtain your pure product, you will need to purify. So here, separation system, it can be a few separation unit. It can be perhaps if your reaction is simple, just to separate two components. So you can simply use distillation column, okay, ordinary distillation column. But if you have mixtures of mixtures of effluent product, then you will need perhaps series of separation units. Okay. Okay, so these three are the main reason why you need separation system, separation process. Okay, so here it mentioned that major investment and operating costs of a process usually will come from the separation equipment rather than the chemical reactors. Because let's say you have only one reactor, but your effluent product have mixtures of components, which you have to separate them in few unit op. So each unit op will cost different. Will have their own parameters, will have their own perhaps utilities required. Okay. Okay, where separations are too difficult, purge streams are used to prevent build-up. If the stream you cannot do separation, just purge the stream. Okay, but you need to check the condition of the stream as well. What is the concentration, whether it is suitable to be purged or not. Yes. For a binary mixture, possible to select a separation method that can accomplish the task with just one piece of equipment. Okay, binary. Binary means what? Two. Okay. If it involves more than two components, then it will involve more complex separation system. Okay, any questions so far? Clear? The separation of reactor effluent. So you will have few phases, various of phases and mixtures. If your effluent contains vapor and liquid mixture, so you can propose to use flash column to separate the vapor and liquid stream. Okay, if you have liquid mixture, you can use decanter. Okay, this is not how to say not compulsory to use. It depends to your product and system as well. Okay, if you have any other suitable separation unit, then you can choose that. So vapor and liquid mixture. The liquid, you have two components. In this example, it suggests you the flash decanter. But if you have slurry, you can use the filter or centrifuge. Okay, the rotary drum filter. Okay, this is just suggestion. There are a few more unit op that can you use. Okay, usually effluence from this separation system, are products which need to send to the storage, or byproduct, or a recycle stream, okay, which are then sent back to the reactor, or separation recycle stream sent to the other separation system. Okay, for example, over here we have feed go into reactor for the reaction process. Then you have effluent. Okay, these effluents perhaps they have a mixtures of vapor, liquid, and some solid. So for the phase separation system, you can choose a suitable phase separation system to separate vapor, liquid, or slurry. Okay, this one only the phase. In the liquid, perhaps you have multi-components or binary mixtures. So here you will go to another separation unit to separate liquid 1 and liquid 2. Okay, so from here you will have your byproduct or main product purify. Byproduct or main product. This purge perhaps liquid 2. Maybe some percentage of liquid 2 left in this stream. So you can just purge the stream. Okay, at a very low concentration. Or some stream you need to recycle. Perhaps here it consists low composition of vapor. So recycle to the vapor separation system. Yes. We will purge up if the product is in very low concentration and it is not worthy to recycle. Okay. So from this liquid separation system, perhaps you have a solid or slurry some here. So you recycle to the solid slurry separation system. So from here, perhaps this is your product or byproduct. Then the remaining solid, if it is useful for the reaction, then recycle to the reactor system. Okay, so basically this shows how from reactor effluent go for separation process. It can be phase, it can be binary or multiple components. Okay, so it is not compulsory to recycle. It depends to your process. If it is worth and feasible to recycle, then opt to recycle. Okay, we use this butane recovery system as example, where we have where it asks to consider the synthesis of separation system for the recovery of butane. Okay, recovery of butanes from a C4 concentrate from the catalytic dehydrogenation of N-butane. Okay, the process feed contains these mixtures: propane, 1-butene, N-butane, trans and cis-2-butene, and pentane. Okay, so this whole thing. We have 6 components. So these are the given properties: boiling point, temperature, pressure. Okay, so here 2 separation methods that is possible is the distillation and extractive distillation. What is extractive distillation? close boiling point. Yeah, they are different. Normal distillation and extractive distillation. Extractive distillation, you need to add something in to help to extract the component. We'll go through in details later on. Okay. The extractive, yes, it used for those components that cannot be separate in normally. That means has very low relative volatility. Okay, here we have the feed with all of these. And this is the amount of the stream. So to separate each of these, you will need to consider the properties over here. As you can see, your main product would be the butenes. Okay, recovery of butenes, which is this. 1 butene, trans 2 butene, and cis 2 butenes. This is the one that you need to recover. Okay, but they have a different boiling point. 1 butene, negative 6.3, whereby the trans and cis, this one. Okay. So from this figure, these are the percentage of the recovery that can be required. Okay, we'll see how we can separate these components. Okay, butenes mixtures means all the butenes over here. Clear? Okay, we go to the first column, the feed from the butane. The feed which contain all of this. Okay. Now, at first column, 1 butane columns. Here, it has 100 tray columns. In this first column, C3 and 1 butane is in the distillate. C3 is what? Yes, propane. Okay. Now we have C3 up here. In distillate, C3 and 1 butane in distillate. Why do you think C3 and 1 butane go to the distillate? Lowest boiling point. Okay, propane, C3, and 1 butane. Okay, so the lowest boiling point will go to up here. You notice the temperature. This is the temperature. I assume this is temperature. Okay, because it doesn't mention the unit. Okay, so here 75 degrees C, and down here is 1 degree C. That's why propane and butane will go to the top. Okay, then this whole thing is in this feed. And butane, trans cis butane, and N-pentane. Okay. Now moving forward, we focus on the distillate first, which is C3 and 1 butane. So C3 and 1 butane enters the next column. 76 degrees C and 150 degrees C. Now it's between propane and 1-butene only. Okay, so here, what do you think will be the top product? Propane. This one will be butane. 1-butene. 1-butene. Okay, wait, let me check. 150 is critical temperature. According to this. Okay, so propane is 97.7. 1-butene is 146. Okay. Okay, notice the difference on the temperature over here. According to this temperature, propane will go to the top because propane has lower boiling point compared to the butane, right? Okay, so that's why butane being recycled back to the first column. It goes to here to further purify. Okay, so here, okay, wait. Both, okay, let me see. 97 and 146. Okay, so here, this stream, the one that go back to the first column, perhaps still consists the leftovers of the butane and propane. Okay, this top product, it will be propane and 1-butene. Yes, mixture. Okay, it purified. In this stream, perhaps it still consists of other components apart from the propane and 1-butene. Okay, so once it goes to here, they will enter the third separation unit, where here it will clearly separate between propane and 1-butene. Okay, so here it will be AB. And this part, it will separate A and B. As A and F. And then this is the AB and the AB balances to A. Correct. Okay, on the first column over here, C1A, it separates AB and here is C, D, E, and F. Okay. Okay, settle on AB. Now, to separate these four items, four components, go to the next separation unit. Okay, and on top of here, 20 and 1. So between C, D, E, F, and butane is the most volatile. Okay, and butane. Yes, and okay. Here, and butane, pentane on top over here. Pentane is F. F, clearly here, it separate F. So top over here is C, D, E, F. Sorry, C, D, E. Okay, C, D, E. Because you see from here, the boiling point for C, D, E, F, pentane is has the biggest gap. That is easier to be separated. F is 36 degree C, the rest less than 4. Okay, so that's why this unit, it separates the pentane first. Easier to separate. Okay, next, we move to the CDE separation. Go to the next column. Here it's separate N-butane. N-butane is what? C. C. This one D, E. C, yeah. Because here for the CDE, C is the most volatile compared to DE. So it removes the C up here. Okay, DE goes to the bottom. So DE will go to the final distillation column where it separates 2-butane is what? D. Where is E?
It's for the second one. It's split.
Which one? Which one? Here. This.
Yeah, this one. You see the arrows only
This one.
6 feet.
Yes. The impurities will go back to here. You can say so. CDE, okay, here might still consist of F for impurities. So it will be recycled back to the column.
Size 6 is
This one. This one, perhaps the remaining of the F go back to here. So to completely remove the F, separate the F. Yeah. Okay, this, yes.
Going into the dehumidizer. I mean, dehumidizer at the bottom there, because the 2-butene is D and E, right?
2-butenes, yes, D and E.
So that the inlet may still have some.
Inlet from?
Inlet the C4. Yeah.
Here.
At bottom, yeah, that one. So the inlet may have seeds, that why but it is small.
Yes. Okay, here why it split it again, perhaps still consists of some C. Okay, so that's why it split it again to go back to this part. And butane is C. Okay, here, this statement, NC4, which is the C, and 2C4, CDE, is CDE, cannot be separated by ordinary distillation because the relative volatility is equals to 1, nearly 1. It is quite hard to separate. It equals to 1. Okay, so they add furfural as an extractive agent. Okay, so this furfural will combine with the butenes. Okay, because these butenes withdrawn as distillate, furfural is recovered as bottom. Furfural will recover as bottom and recycle back to C4. This one is
The P is DE and furfural, that's why it makes more.
which part?
Defensive. The purpose is where you separate DE from furfural.
You mean this one?
Yeah, because They say we add peripheral, right?
Mhm.
So for me, is that right now we want to separate the butynes and peripheral. That's why we have the D-pentylene so that they are that one.
Mm.
So that's to separate the butene from the peripheral.
Furfural, yes. Okay, here the furfural is added because the CDE cannot be separated in ordinary distillation. Okay, this is what it means by the extractive distillation. You need to add something as extractive agent. It should be more than one. Yeah. More than one, it is easier to separate. The ease of recovery. Okay, larger relative volatility, it will be easier to recover. Yes. What is the equation of relative volatility? We'll go through in the next slide. Okay. So this one you have learned in distillation separation last time, right? Okay, just recall back. Any question on this chapter? Sorry, in this slide. Student at the back, please focus and on at the side. I'm not teaching on the front row only. I'm teaching all students. Okay, I sit down because I need to write. If you have any question at the back or anything not clear, just raise up your hand and ask. Okay, this is important for your PDP as well. Okay, can I move to the next slide? Okay, some separation process, it requires some form of energy. It can be ESA or MSA. If the process using the assistance of heat transfer, shuffle, or pressure reduction, which involve the energy, then we call that as ESA, energy separating agent. Okay, energy separating agent. It use energy. But if you have to include or input another agent, another mass, so that one is called mass separating agent. Like the furfural just now, it is MSA, mass separating agent. Okay, the furfural in this slide, furfural is added as the mass separating agent in order to separate the C4 and the butenes. Okay. Or you can also add addition of solid phase, which adsorption can occur. Okay, in adsorption, solid phase means the adsorbent. Okay, that can adsorb the components that you want to separate. Or you can also place a membrane as the barrier. Okay, that one case to case basis. And depending of your components property. Huh?
The first one. Basic.
Is what?
Basic.
Basic distillation.
I understand.
Like ordinary distillation, but you supply perhaps additional pressure reduction or additional heat transfer in order to separate them. Yeah, can consider vacuum distillation where you change the pressure, so the boiling point will change, the temperature will change, right? To separate the components. Yes, different condition.
That one, it would help to like reduce the density of the social follow. So it's like considered as ES for efficiency because you're injecting steam, but at the same time you're reducing the energy separating. I mean, you're reducing the energy consumption as well.
The purpose of the steam is to
It's also the temperature you can use is like much lower than the normal temperature of the steam.
then it will be MSA because you inject mass. Okay. Any further question? Can understand answer? Okay, these are some common industrial separation methods. They have flash distillation. It can be ordinary or extractive or azeotropic. Okay, there are few types of distillation column. You have gas adsorption, stripping. Okay, for example here for gas adsorption, feed condition is vapor. Separating agents, they use liquid adsorbent for the MSA. Okay, so it developed added phase, which is the liquid. Initial phase is vapor. When you add MSA as in liquid form, so you will have additional phase, liquid form. Crystallization. Your input is liquid. You need to crystallize certain components, right? So you need to know the properties to crystallize the component. So you implement the ESA. No mass added over here. It involves the energy. So it is ESA.
What's the S stands for, in the developed or added phase is in heads?
Solid.
That stands for the product, the phase of the product.
From liquid to solid. From liquid phase to solid phase, yeah.
So the developed phase is basically what's the phase of the product.
The phase of the product or the added phase. Like for gas adsorption just now, you want to absorb the gas.
Yeah.
Right. So you add the liquid MSA. So that liquid will absorb the gas. So you have liquid phase of together with the vapor. Removal suspended solid from solution. The what? Okay, for the crystallization here, the phase developed is solid because after the crystallization process from liquid, final phase is solid. Crystallization process, for example, spray dryer, freeze dryer. So from liquid, let's say spray dryer at high temperature, high volume, high pressure, liquid spray, then solid come out. Okay. What?
Yes.
Membrane. Okay. Membrane, liquid or vapor. Okay, sorry. Okay, membrane here we have phase condition of the feed. It can be liquid or it can be vapor as well. Okay, the membrane ESA. Membrane here, you use different pressure to pressure the liquid, to press the liquid to pass through the membrane, right? So that's why it use ESA. What? Concentration. Pressure, that one pressure, right? ESA, yes.
Because it increases the concentration, you actually think that product, right?
The concentration is in your feed, right? You are not adding something new. Something new mass into it.
So whenever it affects the pressure temperature, it's considered ESA. Whenever it affects physically the thing, it's ESA.
Correct. Mass being added to the system, to the process. So for the osmotic pressure, different pressure, so it is ESA. Reverse osmosis as well, right? Okay, you play around with the pressure. Okay. Now, these are the criteria for selection of separation method. Requires selection of separation methods. Okay, what type of separation methods? The ESA or MSA. What type of equipment that you need to use? How is the arrangement or the sequencing of the equipment? And what is the operating conditions? Okay, for number 4 over here, optimal arrangement or sequencing. From here, you see the sequencing. First, it removes A, B, and C, D, E, F. Then it removes A, B, then the rest. Okay, that is the sequence. That means which one to be separate first. Okay, and it has its own arrangement based on the properties of the component. Okay, later on you will see whether perhaps ABCD as distillate, EF as bottom. Then from there separate. Okay, there are many possible sequence. Okay, to select the separation method depends on feed condition, whether your feed is vapor, liquid, or solid. For vapor and liquid, you can use partial condensation. You can use distillation, okay, adsorption. Vapor and liquid, some equipment quite similar. But for solid, you will need to dry it first, usually. If wet, dry it first. Then if dry, you can leach them out. Okay. Now the separation factor is equivalent to the relative volatility. Okay, from here, from this equation, SF, separation factor, Y is the vapor over liquid phase. Okay, vapor for each component over liquid phase for each component. Similar to the relative volatility. Okay, there are a few terms that you will find that you will come across to the SF, the K, and the relative volatility. K over here is reflecting on each component. Okay. The larger the value of SF, more feasible separation operation. SF is equivalent to the relative volatility. Okay. Now next, this one, gamma, this symbol gamma is the activity coefficient component of I. SF, separation factor, is equivalent to alpha. Alpha here is the relative volatility. This one, if go for ordinary distillation, you do not add any MSA. But if you add MSA, the symbol will change to beta. The concept is the same. It's just the symbol, where beta is inclusive with the MSA properties. Okay. Now here, example of application of the MSA. We have here the feed, ethanol, and water. Ethanol boiling point is around 78. Water is 100. So for ordinary distillation, simple distillation will be quite challenging. Okay, because the boiling point is quite near. So they add salt as the MSA, where water and salt, the boiling point will be higher compared to water only. So the purpose of salt here to act as the MSA, mass separating agent. A small amounts of a dissolved salt act as mass separating agent. In the ED here means extractive distillation. Okay, to increase the relative volatility of the more volatile component. So instead of between 78 and 100, now you will have 120 versus 78. Okay, so it will be more easier to separate. Okay. Few other example of the MSA in absorption unit. For example, here separation of CO2 from combustion product using the EA, ethanol amine. CO2 from combustion product. Combustion product, CO2, H2O, and N2. So you want to remove CO2 only. Okay, from here, enter the absorption unit in vapor phase, gas phase. Then MSA enter as liquid phase, the EA. So the EA will absorb the CO2. Okay, EA absorb the CO2. So liquid here will be EA plus CO2. Okay.
Start when we that.
When or where?
Where?
Where? Where it depends to the column and properties of your feed. Because perhaps at this stage has different temperature. Right. Okay, same goes for stripping, where the feed is in liquid form. Okay, this one removal of light ends from naphtha, kerosene, and gas oil. Feed is in liquid, so MSA input is in vapor phase. So it will extract out the light ends. Then it will be in vapor phase. Your final product will be in the vapor phase. Okay. This figure, it shows, they mentioned over here, if SF equals to 2, that means the relative volatility separation factor equals to 2 for ordinary distillation. Ordinary distillation. X exists here refers to relative volatility for ordinary distillation. Y exists over here. It is required minimum relative volatility required for extractive distillation and minimum beta. Beta is when you include the MSA. Okay, so if ordinary is equal to 2, so it must be above 2.3 for extractive distillation. Here. To be an acceptable alternative. And above 18 for liquid extraction. Here, liquid extraction means when you have the beta. Okay, inclusion of the MSA. Okay. Now, these are a few circumstances that not favoring the distillation. There are 5 here. When you have low molecular weight materials, high molecular weight and heat sensitive materials, separation of components with low concentration. Okay, this one will, if you have low concentration, then you want to separate using distillation. It will, how to say, not profit, because you need to set up a distillation column, which costs a lot just to separate a low concentration product. Okay, next is a separation of classes of components. And last one is mixtures of low relative volatility or exhibit the azeotropic behavior. Okay. Now this the selection of equipments. Let me know if I go too fast. Few selection of the equipment. We have adsorption. Okay, then you need to select the adsorbent. What is the strength, the selectivity, okay, activated carbon. You can use silica gel, activated alumina as adsorbent as well. For leaching, it can be batch or continuous, okay, percolation or immersion process. Membrane, liquid-liquid extraction, crystallization, okay, and drying. So if let's say your separation process requires drying, there are few options over here. You can use the fluidized bed, drum dryers, okay, rotary drums, belt dryers. Okay, it depends to your fit and product. Okay. Okay, now I intro a bit on the sequencing of ordinary distillation column. Ordinary here means you don't add any MSA, no additional mass. Okay, one distillation column can be optimized to separate one pair of volatile components. One pair. Usually, if you have two components, one distillation unit is enough. Two fractional recoveries can be specified as this. Okay, fractional recoveries is around this figure. Distillate, it can be up to 0.95. Bottom, this one. If the feed contains more than two volatile components, so more distillation columns, that means the multi-components. Two components, simply you can use one distillation column. But if more than two, it can be series of separation unit. Okay. Okay, you know this term, right? Light key, heavy key. I don't know. You sleep during the class. Light key, heavy key. Light key is the distillate. Heavy key is the bottom. That's another term. Okay, light key, distillate, heavy key is the bottom. Okay, and light key usually is the most volatile keys. Okay, most volatile keys is the product that you want, because you have also here light non-key. Light non-key perhaps your byproduct. Light key is your main product. Okay, light key, and the least volatile is heavy key. Key is your components that you are focusing on, the product that you are targeting on. Okay. Apart from those product is your non-key byproduct. The other components are called non-key. Okay, light non-key is referred when non-key is more volatile than the light key. Whereas heavy non-key is less volatile than the heavy key. Okay, so in questions, sometimes the question will state to you what is the heavy key that you need to recover, perhaps. What is the light key that you need to recover? So from this table, we focus on the light key and the heavy key. So this relative volatility is important for this component. This is the relative volatility. Okay, so here the line over here is the one that will be separated. Light key on the distillate or top. This one is bottom product. Yes. Okay, clear? Okay, from this figure, you see there are different sequence. This is the feed. It's different color. Okay, here is the feed. Let's say your feed has for example, A, B, C, D, for example. So this sequence, it remove A, B, C, D, then B, C, D, B, C. Okay, this sequence. Whereby this sequence, it remove A, B, C, D. Sorry, A, D, A, B, C. Then here A, B, C, B, C. For example, so you see here different sequence. Here we call as direct sequence. This one is indirect sequence. Let me check whether I always wait. Let me check. Let me confirm the term. Where is it? Right here. Direct and indirect sequence. Direct, when your distillate, first column, you already have your distillate component product, one product. Indirect, your bottom is your first product. Indirect. Okay, this one is indirect.